My name is Anthony Brown and I am an assistant professor here at Durham University. My specific area of research is gamma ray astronomy, and in particular gamma ray astronomy with the CTA, with the Cherenkov Telescope Array. So what am I currently doing in CTA? Well, there are several things. We're currently building it. So people within CTA need to be building things and characterizing things and inventing new bits of kit for it. So this is one of the things I work on. I'll start with the drone here. So we are using simple photography drones or UAVs as platforms from which to calibrate CTA. CTA is going to be a large number of telescopes spread over a very large area, and we're coming across a problem of how do we calibrate all of these telescopes at once, because they're spread everywhere. So here in Durham we come up with the idea of using these drones as platforms on which we can house calibration devices to illuminate many telescopes at once and understand what the telescopes are doing, and thus calibrating the whole array. So Durham is leading this airborne calibration of CTA, so it's a very exciting area of research. So why do I think CTA is an exciting project? Well, it's simply because we are probing the most extreme phenomenon within the known universe. Okay, gamma ray photons are very energetic photons. One tera-electron photon that CTA will observe will have the same amount of energy as 1 trillion photons that we see with our eyes. That's a lot of energy in just one photon. And this is in part because of the way in which these photons are produced. Okay, rather than being produced through thermal processes like the light bulbs we have in this room, gamma rays are produced through non-thermal processes, simply because matter cannot be hot enough to emit gamma rays. If it did, it would rip itself apart into its primary product. So gamma rays are produced through non-thermal processes, relativistic particles going close to the speed of light, interacting with other light, with magnetic fields, hadronic particles colliding together to produce these gamma rays. So we're really probing the most extreme processes within our universe. Okay. What's really cool is that here on Earth we've built the Large Hadron Collider, or the LHC, in Geneva, in Switzerland, in France. And that took a lot of time and a lot of money and produces some very exciting results. Now the cool thing is, nature does it all the time. We have those types of LHCs, or particle accelerators, in our own galaxies, in other galaxies, in normal boring galaxies, and galaxies that have supermassive black holes and accelerating particles to close to the speed of light. It happens all the time in nature. So why do I think CTA is an exciting project? Because we're going to be able to go out and see all these particle accelerators around us and